Welcome back. Today we are going to understand about circuit breaker pattern, and we will see a implementation using Spring Boot, Java and Resilience4j. So let's see circuit breaker in action. So for that, let's first understand what is circuit breaker and what is Resilience4j. So for that, let me show you some official website. You can see, do not go to this one, just go to circuit breaker. So here you can see circuit breaker using Resilience4j. So the circuit breaker is implemented via finite state machine with three normal states. One is closed, one is open, and one is half open. So this diagram you can see there is closed circuit, right? So failure rate above a threshold, then it is going to be in open state, and after some time failure rate above a threshold, then it is going to be half open, and if it will try if in the half open state again for the server to be up and running. If it is up and running, then circuit would be closed, otherwise it will go back to the open status. Okay, so here you can see wait after a wait duration, you can see it. Let me simplify it here. I have created something. Yeah. So what I am going to show you, you can see circuit breaker in action. Okay, so what we will do, we will create a simple, I will not create an API gateway. Let me use it here, just a postman. Let me see if there is some diagram for postman here. It is not here. Let me pick it from here only. Yeah, suppose I am using this image only, not this, only this one, not like this. I want something like this. Okay, just to clipboard, let's go back to the diagram here. I want here my postman agent. Okay, command Z, and I can make it so. Okay, let me do one thing. Let me make it smaller. Cool. Now you can understand. So suppose we have postman, client is requesting via postman. Okay, now client is requesting via postman. There are two services, one is user service and one is payment service. And for now, let me remove this DB. I don't want this DB, or just remember, keep in mind that I'm not creating any DB. Just what we are going to have, we have a client, okay, which would request, fire some request on the user service, and then there is a payment service. User service is going to call payment service. If payment service is down, then we will observe what is the status of circuit breaker, open, closed, half open, what are these. So before I'm going to this service which we will make, which would be running on localhost 7070 and 7071, I want you to understand this diagram. What is this circuit closed, open, half open means? So if you remember in the electrical circuit, let me show you just one thing. Electrical circuit, closed and open. Yeah, look at this diagram. If you see here, what is open circuit? If you have a battery, you have a bulb, and you have a key. If this key is open, which is if you have switch on off, if it is off, then circuit is open, and then the current will not flow and the bulb will not light up. Okay, but if it goes like this, you can see here, if it is circuit is closed, then electricity flows through that and the bulb is kind of lit. So the same concept goes to circuit breaker. Okay, the same concept goes to circuit breaker. So here you can see I have shown it, the closed one with green color, because if circuit is closed then our system is up and running. Okay, and then this open is if here in the diagram, if payment service is off. Okay, if payment service is, suppose the server is down or some exception is thrown, that if we are calling some particular API and that is not responding or is responding with some exception, in that case what should be there? So that is the state of open, okay, in circuit breaker. So if service is down, then our circuit breaker comes in open state. And what is half open? If you look here, there is a wait duration in open state. So there is a configuration where we wait for some time in open state. Till how many seconds or how many time this circuit would be in open status. Here you can see t is equal to 10 seconds. So for here, if we can configure it to 10 second, 5 second, whatever we want. So for some time it would be in open state. So here for 10 seconds the circuit would be in open state. After that, all the requests which are coming, it will wait for 10 seconds, and then again automatically it will go to half open. Okay, so max wait duration till after that there is a max wait duration in half open state. You can have after how many time duration it can be in half open state. You can give it like 5 seconds. So after 5 seconds it will retry, it will send the request back to the, here you can see from user service to the payment service. So it will again send the request to the service, and if the service is up and running and it is responding with proper response, then the circuit is closed, the status is closed. Otherwise, if there is failure, this was the case of success, if there is failure, then again this half open will convert to open. We will come back to this once again. Okay, look at this failure threshold is equal to 50%. This is the situation. Suppose I have 5 requests, and if 1 2 3 is greater than 5, 3 requests failed, so we hit this, we reach this failure threshold, and then automatically the circuit will come into open status. Okay, we will come back to this also while while creating and understanding the flow. Cool. So let's create this overall flow which I have shown here. Just we are going to create a client, and which will hit to user service, and then it will go to the payment service. Okay, we will understand when this is down, this icon is for the down one. Threshold, we will understand what is threshold. I already told you. Yeah, let's see, let's create some, let's see the Spring Boot application. Where it is, IntelliJ, let me show it here. Cool. So here you can see we can go on Spring Initializer first and create 2 microservices. Just go to Spring Initializer and create 2 microservices, just like I had used and I had done this. So you can choose the language. If Maven, it is Maven, whatever. Just here you need to give the user service, and for other service which we have here is payment service in the diagram, right? Yeah, user service and payment service. So you can give it, and then you can use Java, whatever you're using. I use Java 21. So just click on, we need some dependencies. So here you can see Resilience4j, where it is. Yeah, this is Resilience4j. You can add Lombok for simpler codes, and then you can have web security for this controller and these things, right? We need Spring AOP, it is not here. Okay, we will independently use that. So Spring AOP we need, and then we can use actuator also. So Spring Boot actuator, these 4 things you will use. And Spring AOP is very important. Because of that there would be a problem for loading the this health status and everything in actuators, and we will see. Okay, so now let me show you the user service. So here you can see I have simple user service which is having simple user application. Once you create and import it in IntelliJ, it would look something like that. So we have a bean for this template just to hit the payment service using get for object or exchange, something like that, for communicating our external microservice which would be running on some other port. And then we have user controller, which is very simple, no complexity, just simple. You can see slash user, and then we have slash call payment. You can look at here, we have this call payment service which is calling payment service. Just look at here, payment service, there's nothing. I have simply used logger, nothing more. And here you can see this method. This is very important method actually. Here you can see I'm calling payment service. This is the exchange which we use, get for object. This is the URL for the payment server or payment service which is running on localhost 7071. Let me show you in the diagram also. Our payment service is running on localhost 7071 and user service is running on 7070. So from user service we are hitting to payment service. So this is the payment microservice localhost, and this is the URL payment/file. I will show you this while we are going for payment controller and payment service. We will see this endpoint, and then if everything goes fine, we are simply returning the service. Okay, now if some exception occurs, then what should be happen? That is, here circuit breakers comes into the play or comes into picture. So this annotation at the red circuit breaker, you can see github.resilience4j, and it is being imported from that, and we have a name is equal to payment service. Here you can give any name, whatever name you want, but there is a mapping. That mapping is very important. That mapping is with the configuration actually. Let me show you the configuration. So here you can see if we have the instances, look at this instances. Here we have payment service, right? So this payment service, suppose I make it to my circuit breaker, something like that. Suppose I do this. So this mapping is very important. It is directly mapped with our service, where it is here. So this name should be mapping. This is just an instance name, nothing more, for circuit breaker to get recognized, like what is the name of the circuit breaker. So you can have my circuit breaker whatever you want. Okay, for simplicity, since we are going to use in we are going to call payment service, that's why I'm naming this to payment service. You can change and try it on your own. Okay, and if there's some error, let me know. So this directly maps with the name here. Okay, and then there is a fallback method which is very important. You can see fallback method, and this is the payment fallback method. Very simple method. Let's go to this payment fallback method. While designing, you can see here this is the fallback method, and look at the signature. The signature should be it is very important actually. Whatever the return type is here, if it is suppose list of a string, suppose it is list of a string, something like this, then what should be the return type? The same return type should be here also for the circuit breaker fallback method. Okay, so this is very important. Keep in mind this return type is strictly, it is must actually. And other than that, if suppose this method signature is also very important here, whatever parameters are there, you write them also. Other than that, you need to have an extra parameter which is exception object. Okay, so you can have exception ex. So suppose I have here string request. Okay, suppose something like that, then what should be the what should be the declaration of definition of this method? It should look like something like this. This parameter included, and other than that, there should be exception x. Cool. So these two things we need to keep in mind while writing the fallback method. These two things. One is return type, and other is this exception. Okay, so here we have written fallback method triggered. So if there is some failure, or if a payment service is not this payment service is, suppose endpoint is down, then payment fallback method should be triggered, and this return should come. If it is coming, then it is successfully working. Our Resilience4j circuit breaker is successfully working. We will see everything. Now let me show you this payment service. Okay, similar way. Okay, one more thing I wanted to show you here, the dependency which we had. Let me show you one time. You can see the dependencies. You can see here, this is for Swagger, nothing more. And then we have this dependency for Resilience4j, Spring Cloud Starter Circuit Breaker Resilience4j, and then payment service. Not, I don't want, I want to show you into the user service. Actually, I was showing you wrong pump for now. Yeah, so here you can see this is for Swagger, and then you can see Spring Boot actuator. You can see this is for health monitoring, everything. And then you need this dependency, Spring Boot Starter AOP. You can see this dependency is very important for circuit breaker to work. Okay, and Lombok we had there. Okay, this dependency I have to, okay, then Resilience4j. Cool. So all the dependencies are there, and now okay, let me move to this application YML file. So look at this YML file. We have our port is running on 70. This is the name of the application. Endpoints, it is including all, and then endpoint health, so details always. So this Spring Boot actuator is going to show all the details related to health. Now this instances we see, now see here base config is default. So here you can see Resilience4j circuit breaker configs, then default. So this default is here only. You can directly remove everything and just write here all the details. That would also work. Here it is kind of more modularized, so no need to worry. Here you can see registered health indicator. There are some parameters. We will come on each one by one. Just see it here for now. Now let me move you to payment service. So the same thing, we have pom.xml, nothing related to nothing related to, no dependency related to Resilience4j here. Just a simple Spring Boot app. Here you can see Spring Boot app, simple class, nothing more. We have payment controller. Inside here we have /payment, one API which is going to have this /payment, right? And then if we hit /payment, there is one method which is get mapping, which is calling make payment. Okay, make payment, you can see make payment random number which is going to be between 15. It's just checking, like just going to create a condition where circuit breaker kind of can happen. Okay, so it is going to simulate a failure. So here you can see payment amount, which is random numbers. If generated numbers are less than 7, then it is going to throw a new exception, which is going to be payment failed. Okay, in that case, in this case, when exception is occurring, in this case what should happen? If the exception is occurring, in the user controller you can see the fallback method should be triggered, right? Why we write fallback method? So that if some exception happens, in that scenario user should not wait, right? There should be some message shown to the client so that he can wait, some message like, okay, the payment service is in you can say fixing mode, or it is in kind of a repairing mode. So something like that message could be shown. So here we are simply showing fallback triggered, payment service is down, this kind of message we can so try later. Okay, so in that scenario, here in the case of exception, if it occurs, then the fallback should be triggered, right? If it is triggered, then it is good, we are working. our circuit breaker is working good, fallback method is working. Okay, and another I have this fail, which is going to be always failing. So this is, I'm just writing here because I want to show you the circuit breaker different states, open, closed, these different states I want to show you. These three, closed, open, half open, I want to show you. That's why I have this method which is always going to fail. Okay, cool. So for now what I am calling, let's see the endpoint. You can see slash payment slash fail, right? So this is the endpoint which we are triggering from the localhost, http localhost 7070 payment fail. Cool. So this is the API which we are hitting, and it is going to throw this exception and something like always failing. Cool. And now let me show the post client. Here postman client, you can see I have postman, and in postman just we are hitting localhost 7070. This is our user, okay, a user service localhost on which user service is running. Here you can see localhost 7070. Also in the configuration, actually we can see why I'm referring to diagram. This is for the payment service. The user service is here. You can see server user service running on 7070. Okay, so this diagram is from the configuration only. Okay, so user service running on 707 and 7070, and local payment service is on 7071. Cool. So the same URL we are creating here in Postman, 7070 user and then call payments. Let's see where it is. It is in the user controller. So we are calling this endpoint, okay, slash user slash call payment. And then since it is the get method, nothing required, it is going to call this user call payment service, and when it enters this one, it is going to call the payment service with endpoint payment slash fail, and it should land on payment service controller, which is this one, and it should land here, right? It should land here. Cool. So this endpoint we are calling. Now let me show you. Okay, let me show you just by sending. Oh, okay, this server is, yeah, cool. You can see the error. Okay, let me delete everything. Okay, now it is going to throw some error and always failing, something like that should be there, right? So you can see from user it is directly called. Let me also have a endpoint here also, so that you can see. Okay, so that you can see that from user service it is landing successfully here only. Okay, let me show it so that that would be greater for you to understand. Not like this. Come baby, come. Yeah. Let me restart in debug mode. Stop the server. Stop. Other eye. Cool. So it's just restarting user server. Now if we hit from postman, there should not be any response. Yeah, could not send request. Cool. Connection refused. Cool. Now it is restarting in debug mode. I just want to show you, if I hit from this, it should land on user controller, and from core payment service, it should land and go to the payment controller, right? Just like this, if you can see here. Just let me show it here. Resume it. Delete everything. Cool. So user service, it is starting, still starting. Cool. Negative profile is default. Cool. It is start initializing. Okay. So now let's send it here. Still starting, it looks like. Cool. Now it is started. Now the request should go. Awesome. Cool. So it is coming on this call payment service, just moving ahead. Awesome. here you can see it is now going to call for this payment fail, right? And when it is going to hit this endpoint, it should land on the payment service controller, which is awesome. Come here, right? Now you can see everything. It is going to fail, so there should be some exception in the consoles. Okay, it is not here, it is here. So fallback method is called here. So exception object is here. You can see the same exception object, the payment failed, something like that. You can see here payment fail API. You can see path internal server error. Internal server error we are getting, okay, which is intentional. But look at this scenario. We have triggered our fallback method, and that is what we wanted, and it's working awesome. Okay, just let's me move the debug. Okay, now the response should be payment fallback triggered, payment services down, which is great. Now let me show you the circuits which I told you. So go to this any browser and then click on localhost /executor/circuit breakers. Okay, so when you click on this, just let me show you the status. You can see it is in half open right now. Okay, and before showing this page, one important thing which is now should be understood is the configuration. Cool. So look here, look everything which is here in the configs and the default. Register health indicator, which is true. Sliding window type is count based. So there are two types of windows which a circuit breaker works. Let me show you that also. Actually, you can see here, okay. So the same thing, you can go through this resilience door. So we are using this one for now. You can see it is kind of hybrid one, but let me go to the diagram once again. Where is count? Oh, we were on the IntelliJ configuration, right? So it is count based. Sliding window type is count based. Now I think you got it. Then sliding window size is 10 and minimum number of calls. Here you can see whatever minimum number it is for the failure, like what should be the if threshold is happening, then what should be the minimum number of calls to fail the service. Okay, we can keep it to 5 or 2, something like that. Now let me take it to be suppose I am taking it 5. Cool. Minimum number of calls which is going to be failed. Okay, and failure rate threshold, this is in percentage, is it 50%? Okay, so understand what does this mean by 50%. Failure rate threshold is 50%. Look at this diagram once again. Okay, this one here we have Postman, we have user service, we have payment service, which is already up and running. Now if failure, you can see failure threshold is 50%. Failure threshold means if user service is sending request and payment service somehow, if it is down or something happened, exception or whatever happened, if it is down, then if suppose 5 requests are sent, okay, if user service sent 5 requests while it is down, payment service is down, then out of 5 requests, this configuration says 5 requests, if threshold reached 50%, out of 5, what is the 50%? Is it 2.5? But if we talk about a request, it is going to be greater than 2. So if failure threshold is greater than 2, right, the third request, when it is going to reach, actually not 2 but 3, 2.5. So if 3 requests are failed, then what it is going to do, it is going in the open state. Cool. Out of 5, if it is configured for 5 requests, if it is configured for 5 requests, then if 3 requests failed, then fallback, our circuit breaker would go, fallback is triggered and our circuit breaker, what it should go, circuit breaker would go into open state. Cool. This, look here, the same thing here. If it is in closed state, it is good, but everything is good. But if there's 5 requests threshold, 50% of incoming requests, 50% of requests failed, then automatically the circuit breaker will go into open state. Cool. Now let's go back to the configuration. Wait duration in open state. Now this property, wait duration in open state, is 10 seconds. Okay, so what does it mean? It means like if request is failing here, payment service is down for 10 seconds or something, like it is down, whatever it is down. So if it is in open state, once the circuit breaker comes in open state, then how much seconds it would wait, or how much time it should wait. So you can see wait duration in open state is 10 seconds. So this circuit breaker would be in open state for 10 seconds on, and after that what would happen? After this delay of 10 seconds, it will automatically come to half open after 10 seconds. Cool. So let's see here the configuration. I hope you got this. And now when it is in half state, half open state, then here is 3. What is 3? This is the number of calls, request calls, which can go to payment service from user service. Okay, so here you can see permitted number of calls in half open state. So how many, uh, here you can see half, if it is in half open state, then how many requests we can say, we can send 3 requests. Okay, 3 requests. So once 3 requests we send, then what will happen? There are 2 scenarios. One scenario is after 3 requests, suppose payment service is, someone started the server or something, like payment service is restored, and after 3 requests, if payment service is restored, then 4th request would be kind of, it is success, and the circuit breaker would come into closed state. If after 3 requests payment service is up, if this payment service is up and running, then circuit is closed, and this is the case of success, and circuit is closed and circuit breaker is open state, and everything is working fine, like this is working fine just like as usual. But if the case of failure is there, suppose after 3 requests, 4th request went and circuit this payment service is still down, this is not up and running, right? In that case, what would happen? If failure comes, then this half open state would change to open state after 3 requests. Cool. Now let me show you. I hope you got this concept. If you don't get, take some time to understand this. Now let's go to the visualization. Okay, it's a visualization in action. Cool. Now let's open this service. You can see this endpoint actuator and then circuit. Just click on it. You can see this is in half state. Okay, it is in half state for now. It is in half state, just like here. Earlier it should be in open state, and after 10 seconds, since I am teaching a lot right now, 10 seconds have been passed, right? Wait duration in open state is 10 seconds. So just 10 seconds are passed, that's why it is automatically come into half open state. Now it's waiting for 3 requests. Okay, 3 request is, here you can see we have given permitted number of calls. So how many calls we can make from user service to payment service, from user service to payment service? It is waiting for 3 requests. Okay, it is waiting for 3 requests. Okay, so let's hit 3 requests, 1 2 3 from the just count 1 a 1. Okay, just let me remove the debug. Actually it should be in debug. Okay, debug point, breakpoints. Just I'm removing the breakpoints because it is hampering that. Not like this. Oh, क्या कर दिया यार? ठीक. Well, let me remove this also because everything is working fine. Cool. So 1 request completed. What is happening? It is still in stuck somewhere. Okay, let me remove it. Okay, I hope, yeah. So fallback triggered, payment service is down. This is good. But count, okay? One request we have sent. Let's see the status here. It should be still in half open, okay? Okay, still in half open. One request we have sent. Let's see another one. Okay, another request we sent. It is in half open. I have sent 3 requests. No, I have sent only one. Okay, let's see. It is in open right now. Let me see that again. After 10 seconds, it should automatically come to half open. Let's wait for 10 seconds because I have configured it for 10 seconds where it is application.yml. This is 10 seconds. Now it should be passed, right? So it should be in half open state. Yeah, it is in half open state. Now 3 requests. Just remember why it is happening. Permitted calls 3 stack. One call, I'm just hitting. Okay, one call completed, 2 calls and 3 calls. Cool. So 3 calls we have done it. It is in half open, remember. Now after 3 calls it is going to be in either open or closed. If payment service is up, then it should be in open, but sorry, closed. Otherwise it should be again open, right? Cool. You can see, since we are all every time we are failing this method, every time we are failing, that's why after 3 requests, 4th request is failing. So since it is failing 4th request, again it is fallback is triggered and this comes to open, and after 10 seconds again what will it will repeat. After 10 seconds it will come to half open. Now since 10 seconds would have been passed, it should be in half open. Look, right? Again let me try. Let me repeat that. 3 requests, 1 2 3. Cool. Now it should be in half open states. Okay, मैं काउंट गलत कर रहा हूँ क्या? And the fourth should be there, right? Half open. However, how many times I will, however, uh, without sending request, it would be in half open, right? And from half open state, what it is going to do, it is going to wait for 3 requests. 1 request, 2 request. 2 बार ही तो क्लिक किया ना, 2 बार में ओपन कैसे हो जा रहा है? Why it is opening? This is not working as expected. 2 is out of 5, suppose. Let me go back to this user service. Out of 5 requests, minimum number of calls is 5. Okay, then it is going to be triggered. So 50% of 5 is what? 2, right? 3, 2.5. But what it would consider? It is considered two requests. Okay, so on 2 it is converting to open. Let me see again. Half open. Okay, sending 1 request only. It should not come to open, but it is coming to open automatically. Why? Is there any problem? I have given some milliseconds. From half open state, it is automatic transfer from open to half open. It is true, which is important. This configuration I have done. Permitted number of calls in open state is 3, and wait duration should be 10 seconds. It is correct actually. Minimum number of calls we have 5, which is just to trigger the fallback. Okay, so if 5 times it is going to fail, then it is going to be in in open state. So I think because of continuously every time it is failing, that's why maybe it is coming. It is in half open state. Let me send the request. Okay, after 1 request it is coming to open. Okay, I'll see into this. Okay, I will look into this, why this is happening. Suppose I have 10 requests. suppose I have 10 requests. Okay, minimum number of calls to reduce this is 10 requests. Again, after 10 requests, actually it is continuously in open state, continuously failing, which I am hitting. So 10 times or more than that it is failing, right? That's why I think it is coming into uh, open state after one request only, but it should not come ideally from half open. It will still be half open. How many times it will try? Other than that, if I hit for one time, fallback is triggered, and this is open. Okay, it is opening. Guys, you can comment down why this is happening, what mistake I'm making. You can tell it. Okay, now let's move for the successful case. Okay, let's see some successful case, like I need to change the endpoint. Actually, I want this payment service sometimes fails, sometimes success, something like that. Let me show you. Suppose not every time it is failing, sometimes it is passing. I want this one also. I want the success scenario. Actually, a lot of failure we have done. Now I want success scenario. I want to show you. So let me hit this payment API from the user one. Service calling this, just remove this one. Cool. Now restarting this one. Cool. Now it's just taking time. Here you can see health. There is another endpoint while it is opening. Let me show you. Also, you can use actuator/health, and you can see discovery unknown, something like that. Our status is up and running, something like that, and readiness. These are the things, and you can hit another endpoint which is metrics. So you can see a lot of things like payment service, which is we are hitting. It is not able to connect because server is restarting. Okay, now let me see if it is started. It is still starting. Yeah, it's just taking time, don't worry. Yeah, now it is started. So everything like actuators, these endpoints should work now. Yeah, successful values are here. Total number of successful calls you can see here. Some metrics are there, so need not to worry. Just focus on this one. This is actually important. So here you can see this initial stage is closed, right? Everything is connected. Payment service is connected. Everything is connected. So initial state is closed. Now let me hit endpoint. Okay, this time this endpoint should be hit, this payment. Okay, and you can see user service payment is success. So normal execution is happening, nothing extra. This payment success, this is happening. Why? Because some number payment amount should be less than 7. So payment amount, you can see if it is less than 7, it is going to show some exception. Otherwise, if it is greater than that, payment success. So something greater than that should be there. Yeah, here you can see random amount is 12. 12 is generated randomly. That's why payment is successful, because greater than 7. Cool. Now let me trigger it. Circuit should still be closed, right? Cool. Now let's send it. Payment is still success. Circuit is still closed. Let me see a failure. Okay, so we got this time failure case, which there should be a number which is less than 7, right? Here you can see again random number generated is 1. So now this circuit is still in closed, right? Why it is closed? Because we need how many times we need this service to be failed? We need this service to be failed for 10 times. Oh my god, what I did this 10 times, it will not fail randomly, right? Because it's impossible kind of scenario to achieve this. I will reduce it again. Yeah, 2 times, 3 times. So it is not going to hit the breakpoint, so its circuit would still be closed. I think you got the scenario like this. There should be continuous 10 failures, right? If continuous 10 failures are there, then only this circuit state would be changed from closed to open, because we want we have configured it for 50% of threshold of that. So first it should be 10 times. Here we have done this 10 times. Let me reduce this to 3 times. Okay, now 3 times, 2 times is okay, because very hard to generate random numbers which are less than 7. Okay, just restarting the payment, sorry, user service. So I'm just reducing this so that we can hit this circuit breaker, so that it can change from circuit can be change state can be changed from close to open and then half open, something like that I want to show. Yeah, it's still loading. So initial case, what I had covered, you can see initial case always failing. So for always failing, whatever the configuration was there in here, I had 2 requests or 5 requests initially and then 10 requests. So since always all the requests are failing, so 10 was easily achieved. That's why minimum number of hours when 10 continuous requests failed, then circuit breaker, what it did, it come from closed state to open state, and after 10 seconds it is automatically going to half open state. And after half open state, when it is in half state open, there are 2 scenarios. One is success, one is failure. So what is, if 3 continuous calls it is going to send, if all the 3 requests are failing, like if payment server is still down or that particular endpoint is not responding, then if continuous 3 calls failed, then it is going to be in open state again. Okay, and when it is in open state, after 10 seconds it will again come into half open state. So this cycle will continue, and if after 3 requests it is going in the 4th request or 5th request, if it is going to be after successful, actually in the case of payment service is up and running, then circuit would be closed again. Cool. So this is the simple concept of circuit breaker. Now it is up and running. Let me hit. We need continuous failures, 2 continuous failures. Okay, one, it is, you can see fallback is triggered. It is still in closed status because it won't be, since 2 requests it is expecting to fail. Okay, then only it will come into open state. Yeah, now 2 requests failed. You can see it should be in open state. Awesome. So it is in open state. After 10 seconds, just wait for 10 seconds. It should automatically, you can see here, automatic transition. So automatic transition would be from open half. It is true. So after 10 seconds, it would automatically come to half open. So let's see, refresh it. 10 seconds passed, half open. Awesome. Now just wait for 3 requests. Okay, just we need 3 failures again, which is impossible kind of thing for generating random things, but we have seen this one, so that's not a I would not say like we have not done this. We have already done this multiple times. Let's see again. 3 failures. Oh, it is success, so circuit should be closed, right? Why it is in half open state still? If we got successfully 3 requests now, payment is success, 2 requests, 3 requests. If payment is success, then it should be closed, right? Yeah, it is closed. I don't know why it is not every time refreshing, but it should close and it is closing. And after this, it is closed. Again the repetition is like, again 2 calls should be failed, then it will come to open. So this repetition is going on. Again 2 times, yeah, 2 times failed, it should be in open state. Yeah, again after 10 seconds, just wait for 10 seconds, it will come to half open, and then from half open, when threshold is hit, here you can see just after one request it would come to open state or closed state. So this is success scenario. Just let me refresh it. It is still in half, payment success, again triggered. And after 10 seconds it's going to be half open. So for closed scenario, what we can see, for closed only it is going to be when the service is up and running, then only it is going to be in closed state. Okay, let me do one thing. What I can do, let me put it down, this server, let me payment service, let me put it down. Let's see what happens if payment service is down. Okay, cool, now it is down. Let's see what is the status. Initially it was closed, right? It is automatically in half open. Okay, when payment service was closed, initial state is the state of this is closed. Now it is in half open. I just want to see if payment service is down, it is calling fallback or not. Okay, so fallback is called, which is great. It is in open state. After 10 seconds it is going to be again in half open. Just refresh it. Yeah, 10 seconds pass. Now threshold, let me go back to our user configuration. Here you can see the number of calls, 2 calls should be failing, right? 1, 2, yeah, 2 calls failed, it should be in open state. Yeah, so it is in open state. Now let me run my payment server again, make it up and running. Okay, check. Let me have a always success scenario also. So some success. Okay, always not runtime, just throw this one. Cool. So this is our scenario, always success. So what I'm going to simulate here, I'm going to simulate the circuit breaker to be closed. Okay, so how can I do that? I can do that by calling the service endpoint, but let's go with the earlier one. Actually 2 times we can get the success, right? Just going with this, I want to see the closed status only, so that now let me run it. Okay, just run it. Okay, half open में होना चाहिए. Yes, it is in half open. I want to see this to be closed right now because our microservice is up and running, and we need only success scenarios. If we do not get any number less than this, okay, less than 7, then we are going to see a success scenario. So let's see. Still got fallback triggered 2 times. Open state after 10 seconds, going to be in half open. Let's wait. Yeah, now we want success request. Okay, this is success, what it is saying. Still half open, it should be closed. Oh yeah, now it is closed. Okay, so this was, guys, the practical implementation of circuit breaker. I think you got it. You try to copy it or you try to work your own and understand the concept. The concept was, the major things were the concept, like what are these state. Actually understanding the state was very important. This triangular diagram, you can see what is open state, half open state, closed state, and how circuit breaker comes to different states, and the configuration you understand. I hope you understand it well. Cool. See, so I hope you got what you had come for here. That's the closing, guys. Have a great day. Have a wonderful day. Just keep rolling on.